In the shadow of the Cold War's final decade, a revolutionary machine began taking shape in the classified workshops of American aerospace giant. The F-22 Raptor, officially designated the Lockheed Martin F-22A, would emerge as the most technologically advanced fighter aircraft ever conceived, a predator so sophisticated that it would fundamentally alter the mathematics of air combat. This angular, sharp-edged hunter represented the culmination of decades of stealth research, advanced materials science, and aerodynamic innovation compressed into a single airframe that could dominate the skies through invisibility, speed, and precision. The F-22's genesis began with the Advanced Tactical Fighter Program of 1981, but the machine that would ultimately bear the Raptor name took definitive shape on April 23, 1991, when Lockheed Martin's YF-22 demonstrator was declared the winner of the most competitive fighter aircraft competition in aviation history. The decision marked the beginning of a development journey that would consume over 2 decades and $67 billion, producing an aircraft so advanced that it would remain classified in many respects even after entering operational service. The F-22 Raptor that rolled out of Lockheed Martin's Marietta, Georgia facility represented a fundamental reimagining of what a fighter aircraft could be. At 62 feet in length with a 44-foot wingspan, the machine possessed proportions that seemed almost alien compared to conventional fighters. Its angular fuselage, devoid of curves or rounded surfaces, had been shaped entirely by the demands of radar stealth rather than traditional aerodynamic principles. Every line, every angle, every surface treatment served the primary purpose of scattering electromagnetic energy away from enemy sensors. The aircraft's distinctive diamond-shaped wings, swept at 42 degrees, provided the lift characteristics necessary for high-altitude, high-speed operations while maintaining the sharp edges that radar waves would slide off rather than reflect back to their source. The vertical stabilizers, canted outward at precisely calculated angles, served both as control surfaces and radar deflectors, their positioning determined by complex computer modeling that balanced aerodynamic efficiency with electromagnetic invisibility. The F-22's stealth characteristics extended far beyond external shaping into materials science that pushed the boundaries of what was technologically possible in the 1990s. The aircraft's skin consisted of radar-absorbing materials that could capture electromagnetic energy and convert it to heat rather than reflecting it back to enemy sensors. These materials, whose exact composition remains classified, required precision manufacturing techniques that made each F-22 a masterpiece of industrial craftsmanship, costing approximately $150 million per unit in flyaway costs. Beneath this stealthy exterior lay power plants that redefined what was possible in military aviation. Twin Pratt & Amp, Whitney F-119PW-100 engines, each generating over 35,000 pounds of thrust, provided the raw power necessary for the F-22's most revolutionary capability: sustained supersonic cruise without afterburner. This super cruise ability allowed the Raptor to maintain speeds exceeding Mach 1.5 for extended periods, giving it tactical advantages that no previous fighter had ever possessed. The F-119 engines incorporated thrust vectoring nozzles that could redirect exhaust flow up to 20 degrees in the vertical plane, providing the F-22 with maneuverability characteristics that seemed to defy the laws of physics. These rectangular nozzles, shaped like flattened diamonds, not only enhanced the aircraft's agility but also contributed to its stealth signature by mixing hot exhaust gases with cooler ambient air more effectively than conventional round nozzles. The Raptor's avionics suite represented the most advanced integration of sensors, processors, and displays ever installed in a single aircraft. The AN/APG-77 radar system could detect, track, and engage multiple targets simultaneously at ranges exceeding 100 miles while maintaining the aircraft's low radar cross-section through advanced frequency management and beam steering technique. This radar, combined with the AN/ALR-94 passive sensor suite, provided F-22 pilots with situational awareness that extended far beyond visual range in all directions. The cockpit that housed this technological marvel had been designed around human factors research that recognized the pilot as the most critical component in the entire weapon system. The glass cockpit featured 4-color multifunction displays that could present tactical information, flight data, weapon status, and sensor imagery in formats optimized for rapid comprehension and decision-making. The head-up display projected critical flight and targeting information directly onto the pilot's field of view, allowing continuous monitoring of essential data without looking down at instruments. Perhaps most remarkably, the F-22 achieved this unprecedented capability while maintaining the size and weight characteristics of a conventional fighter aircraft. At a maximum takeoff weight of 83,500 pounds, the Raptor was actually lighter than many fourth-generation fighters despite carrying far more advanced technology. This weight efficiency reflected revolutionary advances in materials science, structural design, and systems integration that maximized capability while minimizing mass. The first F-22A production aircraft, tail number 91-4001, took flight on September 7, 1997, from Dobbins Air Reserve Base in Georgia. This maiden flight validated years of computer modeling, wind tunnel testing, and prototype development, proving that the radical design concepts embedded in the Raptor could translate into actual flight performance. The test pilot, Paul Metz, reported flight characteristics that exceeded all expectations, with the aircraft demonstrating stability, responsiveness, and performance that surpassed anything he had previously experienced. Production of the F-22 Raptor began in 2001 at Lockheed Martin's final assembly facility in Marietta, where each aircraft underwent manufacturing processes that resembled precision watchmaking more than traditional aircraft production. The stealth coatings required controlled environment application, the structural components demanded tolerances measured in thousandths of inches, and the avionics integration necessitated testing procedures that verified thousands of individual systems and subsystems. The F-22's operational debut came on December 15, 2005, when the aircraft achieved initial operating capability with the 27th Fighter Squadron at Langley Air Force Base, Virginia. This milestone marked the beginning of the Raptor's transformation from experimental technology demonstrator to operational weapon system capable of projecting American air power globally. The 27th Fighter Squadron, nicknamed the Fighting Eagles, became the world's first operational F-22 unit and the guardians of capabilities that would redefine air superiority doctrine. From its first operational deployment, the F-22 Raptor demonstrated performance characteristics that exceeded even the optimistic projections of its designers. The aircraft could climb to 50,000 feet in less than 2 minutes, cruise at supersonic speeds for hours without refueling, and engage multiple targets simultaneously while remaining undetected by enemy sensors. This performance envelope created tactical possibilities that had never existed in the history of air warfare, allowing single F-22s to control airspace volumes that previously required entire squadrons of conventional fighters. The technological sophistication embedded in every F-22 reflected decades of American investment in advanced materials, manufacturing processes, and systems integration. The aircraft incorporated over 4 million lines of computer code, utilized materials that had been developed specifically for this program, and integrated technologies that remained at the cutting edge of what was possible in aerospace engineering. The result was a machine that represented not just an advance in fighter aircraft design, but a fundamental leap forward in the application of technology to military aviation. As the F-22 Raptor entered operational service, it carried with it the hopes and investments of a nation determined to maintain air superiority in an increasingly dangerous world. The machine that emerged from this effort exceeded all expectations, creating capabilities that would influence military aviation for generations to come while establishing new standards for what was possible when unlimited resources met unlimited ambition in the pursuit of technological excellence. The F-22 Raptor's revolutionary capabilities emerged from engineering breakthroughs that pushed multiple technologies beyond their previous limits simultaneously. Every system aboard this angular predator represented a quantum leap in capability, from the radical stealth design that made it nearly invisible to radar, to the advanced engines that allowed sustained supersonic flight without afterburner. The integration of these technologies into a single airframe required solving problems that had never been encountered in aviation history, creating a machine that seemed to belong more in science fiction than on operational flight lines. The heart of the F-22's stealth capability lay in its radar cross-section reduction, achieved through a combination of revolutionary shaping and advanced materials that absorbed or redirected electromagnetic energy. The aircraft's RCS measured less than 0.0001 square meters from frontal aspects, smaller than a steel marble and roughly 1/10,000th the radar signature of conventional fighters. This invisibility was achieved through meticulous attention to every detail that could potentially reflect radar waves back to their source. The Raptor's distinctive angular surfaces were designed using sophisticated computer modeling that calculated how electromagnetic waves would interact with every facet of the aircraft's exterior. The famous sawtooth edges found throughout the design, on weapon bay doors, landing gear panels, and access hatches, ensured that radar energy would be scattered in directions away from enemy receivers. Even seemingly minor details like antenna placements, pilot tube positions, and static ports were integrated into the overall stealth design philosophy. The materials science that enabled F-22 stealth represented decades of research into radar-absorbing materials that could function under the extreme conditions of high-speed flight. These RAM coatings, applied in multiple layers across critical aircraft surfaces, contained microscopic structures designed to trap electromagnetic energy and convert it to heat rather than reflection. The exact composition remains classified, but the materials required regular maintenance and careful handling that added complexity to F-22 operations. Beyond external stealth measures, the F-22's internal architecture contributed significantly to its low radar signature. The aircraft's weapons bays, capable of carrying 6 AIM-120C AMRAAM missiles and 2 AIM-9 Sidewinder missiles, kept munitions completely enclosed within the fuselage until moments before launch. This internal carriage eliminated the radar reflections that external weapons pylons would create while maintaining the clean lines essential for supersonic performance. The F-22's supercruise capability, perhaps its most tactically significant advantage, resulted from the marriage of the Pratt & Amp Whitney F-119 engines with an airframe optimized for sustained supersonic flight. The F-119 powerplants incorporated advanced materials and manufacturing techniques that allowed them to operate efficiently across a broader range of speeds and altitudes than any previous military engine. Each engine featured a 3-stage fan, 6-stage compressor, and single-stage turbine arrangement that balanced power output with fuel efficiency. The thrust vectoring system integrated into each F-119 engine represented mechanical engineering at its finest. The rectangular nozzles could redirect engine thrust up to 20 degrees above and below the horizontal plane through hydraulically actuated paddles that deflected the exhaust flow. This capability allowed F-22 pilots to perform maneuvers that seemed to violate basic principles of aerodynamics, including controlled flight at angles of attack that would cause conventional aircraft to stall unrecoverably. The avionics suite that transformed raw sensor data into tactical information represented the most advanced information processing system ever installed in a fighter aircraft. The Common Integrated Processor, manufactured by Raytheon, contained dual PowerPC processors running at 66 MHz, cutting-edge performance for the 1990s development timeframe. This computer processed inputs from dozens of sensors and systems, correlating information to create a comprehensive tactical picture that extended far beyond what any human pilot could perceive unassisted. The AN/APG-77 radar system, built by Northrop Grumman, incorporated active electronically scanned array technology that allowed simultaneous tracking of multiple targets while maintaining the aircraft's stealth characteristic. Unlike conventional radars that mechanically rotated antenna dishes, the APG-77 used thousands of individual transmitter/receiver modules arranged in a flat panel that could electronically steer its beam instantaneously. This capability enabled the F-22 to track up to 20 targets simultaneously while engaging multiple threats with beyond visual range missiles. The ALR-94 passive sensor suite complemented the active radar by detecting and analyzing electromagnetic emissions from enemy radars, communications systems, and missile guidance systems. This system could identify and classify threats at ranges exceeding 250 miles, providing F-22 pilots with early warning of enemy activity while maintaining complete emissions silence. The integration of passive and active sensors created situational awareness that no previous fighter aircraft had ever achieved. F-22 flight controls represented a revolutionary departure from conventional aircraft design philosophy. The aircraft was intentionally designed to be aerodynamically unstable in certain flight regimes, relying entirely on fly-by-wire computers to maintain controlled flight. This instability, managed by quadruple redundant flight control computers updating control surface positions 80 times per second, provided the extreme maneuverability necessary for air-to-air combat while maintaining the precise control needed for accurate weapons delivery. The cockpit design philosophy prioritized information management and pilot workload reduction through advanced human-machine interface concept. The four-color multifunction displays could be configured to show tactical information, system status, sensor imagery, or detailed aircraft performance data according to mission requirements and pilot preferences. Voice recognition technology allowed pilots to execute certain commands through speech, reducing the need to manipulate controls during critical phases of combat. The F-22's electronic warfare capabilities were integrated seamlessly into its overall design rather than added as external systems. The ALR-94 passive sensor suite could function as a sophisticated jamming system, using the aircraft's own transmitters to disrupt enemy radar and communications systems. This capability, combined with the Raptor's stealth characteristics, created electronic warfare effects that could protect not only the F-22 itself but also nearby conventional aircraft operating in the same airspace. Manufacturing processes developed specifically for F-22 production incorporated precision techniques that had never been applied to fighter aircraft construction. The stealth coatings required application in environmentally controlled facilities with humidity and temperature precisely regulated to ensure proper adhesion and performance. Structural components were machined to tolerances measured in thousandths of inches, while electronic systems underwent testing procedures that verified functionality under conditions ranging from Arctic cold to desert heat. The F-22's fuel system design reflected the complex requirements of supersonic cruise operations and stealth maintenance. The aircraft carried over 18,000 pounds of fuel in internal tanks that were shaped and positioned to maintain proper weight distribution throughout the flight envelope. The fuel management system automatically transferred fuel between tanks to maintain optimal center of gravity positioning during different phases of flight, ensuring stable handling characteristics from takeoff through combat maneuvering. Structural engineering challenges unique to the F-22 included managing the heat generated by sustained supersonic flight and the mechanical stresses imposed by thrust vectoring operations. Advanced titanium alloys and composite materials were used throughout the airframe to provide strength and heat resistance while minimizing weight. The aircraft's structure was designed to withstand G-forces exceeding 9 positive and 3 negative Gs, while maintaining the precise alignment necessary for stealth effectiveness. The logistics and maintenance philosophy developed around F-22 operations acknowledged the aircraft's technological complexity while striving to achieve reasonable availability rate. Specialized test equipment, uniquely trained technicians, and carefully controlled maintenance environments were required to preserve the Raptor's advanced capabilities. This maintenance burden, while substantial, was offset by the aircraft's superior reliability compared to earlier generations of high-performance fighters. Quality control procedures for F-22 production exceeded any standards previously applied to military aircraft manufacturing. Each completed aircraft underwent comprehensive testing that included radar signature verification, avionics functionality checks, engine performance validation, and flight control system certification. These procedures ensured that every F-22 delivered to operational units met the exacting standards necessary to achieve its revolutionary capabilities. The technological integration achieved in the F-22 Raptor represented more than the sum of its individual systems. It created synergistic capabilities that fundamentally altered the possibilities of air combat. The machine that emerged from this engineering tour de force established new benchmarks for what was achievable when unlimited resources met unlimited ambition in pursuit of absolute air superiority. The transformation of the F-22 Raptor from experimental technology demonstrator to operational war machine began in earnest on December 15, 2005, when the aircraft achieved initial operating capability with the 27th Fighter Squadron at Langley Air Force Base, Virginia. The Fighting Eagles, as the squadron was known, became the guardians of the world's most advanced fighter technology and the first to translate the Raptor's revolutionary capabilities into real-world combat doctrine. What followed was a learning curve that would rewrite the rules of air warfare and establish the F-22 as the most dominant air superiority platform ever deployed. The early operational years revealed both the immense potential and the unique challenges of integrating such advanced technology into routine military operations. F-22 pilots, hand-selected from the Air Force's most experienced fighter pilots, underwent training programs that lasted nearly 2 years and covered everything from basic aircraft systems to advanced tactical employment technique. The complexity of the Raptor's avionics suite meant that achieving true proficiency required mastering information management skills that had never been necessary in previous generation fighters. Colonel Dave Alvin, one of the first operational F-22 pilots, described the transition from conventional fighters to the Raptor as like upgrading from a sports car to a spacecraft. The situational awareness provided by the aircraft's sensor suite allowed pilots to track dozens of aircraft simultaneously across hundreds of miles, creating tactical pictures that resembled air traffic control displays more than traditional fighter radar scope. This unprecedented visibility into the battlespace required new mental models for processing and acting upon information at speeds that challenged human cognitive limit. The F-22's first operational deployment came in February 2007, when 12 Raptors from the 27th Fighter Squadron deployed to Kadena Air Base in Okinawa, Japan. This deployment, designated as the aircraft's first Pacific Presence mission, served multiple purposes: demonstrating American commitment to regional allies, providing valuable training in long-range deployment operations, and showcasing the F-22's capabilities to potential adversaries. The deployment required extensive logistical planning due to the specialized maintenance equipment and trained personnel necessary to support Raptor operations overseas. During the Kadena deployment, F-22 pilots participated in numerous training exercises with Allied air forces, providing the first real-world validation of the aircraft's combat capabilities against dissimilar aircraft type. In simulated combat scenarios, individual F-22s routinely achieved kill ratios exceeding 20 to 1 against conventional fourth-generation fighters. These results were so lopsided that exercise planners had to impose artificial constraints on F-22 employment to create realistic training scenarios for opposing forces. The Raptor's combat debut came on September 22, 2014, during Operation Inherent Resolve, the coalition campaign against ISIS targets in Syria and Iraq. F-22s from the 1st Fighter Wing at Langley Air Force Base struck ISIS command centers, training facilities, and staging areas using precision-guided munitions delivered from altitudes that kept the stealthy fighters well beyond the range of enemy surface-to-air missiles. The mission marked the first time F-22s had dropped weapons in anger, validating years of development and training in a matter of hours. The Syrian strikes demonstrated capabilities that had been theoretical until that moment. F-22s operated in contested airspace containing advanced Russian-supplied air defense systems, including SA-22 and SA-17 surface-to-air missiles, while remaining completely undetected throughout the mission. The aircraft's stealth characteristics allowed them to penetrate Syrian airspace, deliver precision strikes, and withdraw without ever appearing on enemy radar screens. This invisibility provided tactical options that had been impossible for previous generations of strike aircraft. Major Jason Markson, one of the pilots who flew the initial Syrian strikes, later described the experience as surreal. The F-22's stealth capabilities meant that enemy forces had no indication of incoming attack until weapons began detonating on target. The psychological impact of this invisible precision proved as significant as the physical destruction, as ISIS forces realized they faced an adversary that could strike without warning from any direction at any time. The F-22's air-to-air capabilities received their first real-world validation on February 4, 2023, when Major General Patrick Ryder confirmed that an F-22 had successfully intercepted and destroyed a Chinese spy balloon off the coast of South Carolina. The engagement, conducted at approximately 58,000 feet altitude, demonstrated the Raptor's ability to engage high-altitude targets while maintaining complete control over the engagement parameters. The pilot, whose identity remained classified, used a single AIM-9X Sidewinder missile to destroy the balloon, showcasing the precision and restraint possible with advanced weapon systems. The balloon intercept highlighted several unique aspects of F-22 operations that differentiated it from conventional fighters. The aircraft's supercruise capability allowed it to reach the engagement altitude quickly while maintaining sufficient fuel reserves for extended operations. The advanced radar and sensor suite provided detailed tracking and identification of the target, while the stealth characteristics ensured that the F-22 could approach and engage without being detected by any defensive systems the balloon might have carried. Training evolution throughout the F-22's operational history reflected lessons learned from both combat operations and extensive exercise participation. The Red Flag exercises at Nellis Air Force Base became laboratories for developing F-22 employment tactics, with Raptor pilots learning to maximize their aircraft's advantages while compensating for its few limitations. These exercises revealed that traditional air combat tactics, developed around visual range engagements and radar limitations, required fundamental revision when applied to stealth aircraft operations. The development of fifth-generation tactics represented a paradigm shift in air combat thinking. F-22 pilots learned to exploit their aircraft's stealth and sensor advantages by operating as quarterback aircraft that could detect and engage threats while directing the actions of less capable friendly aircraft. This force multiplication role allowed small numbers of F-22s to provide air superiority coverage for much larger formations of conventional aircraft, maximizing the tactical impact of the limited number of Raptors available. Pilot accounts from operational deployments consistently emphasized the psychological advantages provided by F-22 capabilities. The knowledge that they were operating an aircraft that could engage any threat while remaining undetected created confidence levels that affected decision-making and risk tolerance. Conversely, the presence of F-22s in a combat theater created uncertainty and caution among potential adversaries who could never be certain whether Raptors were present in their area of operations. The F-22's role in maintaining air superiority over contested regions became particularly evident during deployments to Eastern Europe following Russian actions in Ukraine. Beginning in 2014, F-22s regularly deployed to NATO airbases in Poland, the Baltic states, and Romania, providing reassurance to allies while demonstrating American commitment to regional security. These deployments served as powerful deterrent signals, as the presence of even a small number of F-22s fundamentally altered the air power balance in any region where they operated. Maintenance and logistics lessons learned during operational deployments led to significant improvements in F-22 supportability. Early deployments revealed challenges in maintaining stealth coatings under field conditions, leading to the development of portable maintenance facilities and revised procedures for preserving radar-absorbing materials. The specialized nature of F-22 systems required extensive cross-training of maintenance personnel and the development of redundant capabilities to ensure mission readiness during extended deployment. The integration of F-22s into joint and coalition operations required extensive coordination and training with other services and allied air forces. The aircraft's advanced capabilities created new possibilities for joint operations while imposing new requirements for information sharing and tactical coordination. F-22 pilots became skilled at operating as part of larger force packages while maintaining the emissions discipline necessary to preserve their stealth advantages. Combat mission planning for F-22 operations evolved to emphasize the aircraft's unique capabilities while accounting for its operational constraints. The limited number of available aircraft meant that F-22 missions were carefully planned to achieve maximum strategic and tactical impact. Mission planners learned to leverage the Raptor's stealth and sensor capabilities to gather intelligence, provide early warning, and eliminate high-value threats that would be inaccessible to conventional aircraft. As the F-22 matured operationally, it became clear that the aircraft represented more than just a technological advancement. It embodied a new approach to air warfare that emphasized quality over quantity, stealth over speed, and information dominance over traditional fighter tactics. The lessons learned from its operational employment would influence fighter aircraft design and air combat doctrine for generations to come, establishing the F-22 Raptor as not just a superior fighter, but as the foundation for understanding how advanced technology could be translated into decisive military advantages. The years following the F-22 Raptor's combat debut witnessed a profound evolution in both the aircraft itself and the doctrines surrounding its employment. As the world's geopolitical landscape shifted and new threats emerged, the silver-winged Predator adapted, growing deadlier and more sophisticated with each passing season. What had begun as an air superiority fighter designed to dominate Soviet-era threats transformed into something far more versatile, a multi-dimensional weapon system capable of reshaping entire theaters of operation through its mere presence. By 2015, the F-22 fleet had accumulated enough operational experience to reveal patterns that would fundamentally alter how air power was conceived and applied. Squadron commanders began documenting engagement profiles that defied traditional understanding of air combat. In one particularly revealing exercise over the Nevada desert, a single F-22 pilot managed to kill an entire enemy air wing of 16 aircraft without ever being detected, using nothing more than the aircraft's passive sensors and long-range missiles. The enemy pilots, flying state-of-the-art fourth-generation fighters, never even knew they were under attack until exercise controllers informed them they had been eliminated. These demonstrations of capability began attracting attention from the highest levels of military leadership and political decision-makers. The F-22 was no longer merely an advanced fighter. It had become a strategic asset whose deployment carried diplomatic weight equivalent to positioning an aircraft carrier battle group. Foreign military attaches and intelligence services tracked F-22 movements with the same intensity they once reserved for nuclear weapon deployments, understanding that the arrival of even a handful of Raptors could fundamentally alter the military balance in any region. The aircraft's reputation grew through whispered accounts from opposing pilots who had encountered F-22s during international exercises. These stories, passed through professional networks and military journals, painted pictures of an almost supernatural adversary. Veteran pilots with thousands of hours in advanced fighters described the unsettling experience of having their aircraft die in simulated combat without ever seeing their opponent. The psychological impact extended far beyond individual encounters, creating a deterrent effect that military strategists had never before experienced with conventional aircraft. Captain Jennifer "Killer" Avery, one of the first female F-22 pilots to achieve combat mission qualification, described the unique burden and privilege of flying the world's most advanced fighter. "Every time we launch, we're not just flying a mission, we're representing the absolute cutting edge of what's possible in aerial warfare," she explained. "The aircraft makes you feel invincible, but the responsibility is enormous. You know that enemies are studying every detail of how we operate, looking for weaknesses they can exploit or capabilities they need to counter." The F-22's sensor fusion capabilities continued evolving through software updates that enhanced the pilot's ability to process and act upon information. Advanced algorithms learned to distinguish between significant threats and background noise, presenting pilots with increasingly refined tactical pictures. The aircraft's computer systems began predicting enemy movements based on observed patterns, providing recommendations for optimal engagement solutions. These artificial intelligence enhancements transformed the F-22 from a platform that simply collected information into one that actively analyzed and interpreted the battlespace. Maintenance crews developed an almost mystical relationship with their assigned aircraft, learning to read subtle signs that indicated when stealth coatings needed attention or when internal systems required adjustment. The specialized knowledge required to maintain F-22s created an elite community within the Air Force, with maintenance technicians earning reputations similar to those of fighter pilots themselves. These unsung heroes worked in climate-controlled hangars, using techniques and materials that remained classified, ensuring that each Raptor maintained its invisibility to enemy sensors. The aircraft's combat record expanded beyond its initial strikes in Syria and Iraq as global tensions increased. F-22s began appearing in unexpected locations, their deployments serving as clear signals of American resolve. When tensions flared in the South China Sea, Raptors materialized at Andersen Air Force Base in Guam, their presence immediately cooling aggressive rhetoric from potential adversaries. Similarly, during crises in Eastern Europe, the distinctive silhouette of F-22s on NATO airfields served as powerful reminders of alliance commitment. Intelligence analysts studying F-22 operations noted patterns that revealed the aircraft's true strategic value. Unlike previous generations of fighters that achieved deterrence through visible displays of force, the Raptor's power lay partly in its invisibility. Adversaries could never be certain whether F-22s were present in their operating area, forcing them to assume the worst-case scenario and plan accordingly. This uncertainty paralyzed enemy decision-making processes and limited their operational freedom in ways that massive formations of conventional aircraft could never achieve. The F-22's ability to gather intelligence while remaining undetected opened entirely new categories of military operations. Raptors began flying reconnaissance missions deep into contested airspace, their sensors collecting detailed information about enemy capabilities while remaining completely invisible to defensive systems. These intelligence-gathering flights provided military planners with unprecedented insights into adversary capabilities and intentions, often revealing information that could never be obtained through satellite surveillance or human intelligence network. Training programs evolved to emphasize the F-22's role as a force multiplier rather than simply a superior fighter. pilots learned to coordinate with unmanned systems, directing swarms of drones while remaining hidden from enemy detection. This quarterback role allowed single F-22s to command entire aerial battlefields, orchestrating complex operations involving dozens of platforms while maintaining the stealth discipline necessary to preserve their invisibility. The psychological warfare aspects of F-22 operations became increasingly sophisticated as commanders learned to leverage the aircraft's reputation. The mere announcement of F-22 deployments to troubled regions often achieved diplomatic objectives without requiring actual combat operations. Foreign military leaders, understanding the implications of facing an invisible opponent, frequently modified their own behavior to avoid confrontations they knew they could not win. As the F-22 program matured, it became clear that the aircraft had transcended its original design objectives to become something unprecedented in military history, a weapon system that achieved strategic effects through its very existence rather than its employment. The Silver Ghost had evolved from an air superiority fighter into an instrument of policy, capable of shaping international relations through carefully orchestrated displays of presence and capability. The Raptor's influence extended into realms that its original designers never anticipated, reshaping not only how air warfare was conducted but how nations approached conflict itself. In the shadowy world of 21st-century geopolitics, the F-22 had become the ultimate chess piece, rarely moved, but whose presence on the board fundamentally altered every other player's calculations. The apex predator had found its true calling not just as a hunter, but as the silent guardian of a new order in the skies. The late 2010s brought both triumph and tribulation to the F-22 Raptor program, as the world's most advanced fighter faced challenges that no amount of technological sophistication could entirely overcome. While the aircraft continued to dominate every engagement and exercise, a growing chorus of critics questioned whether the astronomical costs of maintaining such a small fleet could be justified in an era of budget constraints and evolving threat. The debate surrounding the Raptor's future would reveal uncomfortable truths about modern warfare, defense procurement, and the price of maintaining technological supremacy. The most painful revelation came not from enemy action but from friendly fire, literally and figuratively. On November 16, 2010, the aviation community was shaken by the crash of F-22A serial number 06-4125 in Alaska, piloted by Captain Jeffrey Haney. The accident investigation revealed a cascading series of system failures that highlighted the complexity and interconnectedness of the Raptor's advanced systems. The pilot's inability to receive adequate oxygen due to a malfunction in the aircraft's onboard oxygen generation system led to spatial disorientation and ultimately, tragedy. This incident was not isolated, and similar oxygen system problems plagued the F-22 fleet for years. The oxygen system crisis forced an unprecedented grounding of the entire F-22 fleet in May 2011, leaving America's most advanced air superiority fighters sitting idle in hangars while engineers desperately searched for solutions. For nearly 5 months, the Air Force's premier air dominance platform was sidelined by a problem that seemed almost mundane compared to the sophisticated threats the aircraft was designed to counter. Pilots who had once felt invincible in their stealth cocoons now faced the sobering reality that their greatest enemy might be the very systems designed to keep them alive. Technical investigations revealed that the F-22's life support systems, designed to operate at the extreme altitudes and performance levels that define the aircraft's capabilities, were pushing the boundaries of what was mechanically feasible. The onboard oxygen generation system, which concentrated oxygen from ambient air rather than relying on stored supplies, occasionally delivered contaminated air to pilot. The symptoms, ranging from confusion and euphoria to complete incapacitation, created scenarios where the world's most capable fighter pilots found themselves unable to operate their aircraft safely. Master Sergeant Rebecca Torres, a life support specialist who worked on resolving the oxygen system crisis, described the challenge in stark terms. We were dealing with systems that operated in environments no human was designed to survive. The F-22 could go higher and faster than any fighter before it, but keeping the pilot conscious and alert at those extremes required technology that was still experimental. Every solution we tried created new problems, and every problem we solved revealed 3 more we hadn't considered. The resolution of the oxygen crisis required fundamental redesigns of multiple aircraft systems and the implementation of backup procedures that restored pilot confidence. However, the experience left lasting scars on the F-22 community. Pilots who had once pushed their aircraft to absolute performance limits now flew with heightened awareness of their own vulnerability. The psychological impact was profound. The aircraft that made its pilots feel superhuman had reminded them, in the most visceral way possible, of their mortality. Simultaneously, budget pressures mounting from prolonged military operations in Iraq and Afghanistan began targeting the F-22 program with increasing intensity. Secretary of Defense Robert Gates, a pragmatic leader focused on current rather than future threats, became the program's most formidable opponent. In 2009, Gates successfully convinced Congress to terminate F-22 production at 187 aircraft, arguing that the Air Force's emphasis on preparing for conventional warfare against sophisticated opponents was misplaced in an era dominated by counterinsurgency operations. The production termination decision sparked fierce debates within military and political circles that revealed fundamental disagreements about America's future security challenges. Proponents of continued production argued that 187 aircraft was insufficient to maintain air superiority against emerging threats, particularly as China and Russia developed their own advanced fighter programs. Critics countered that the F-22's extraordinary cost per aircraft, estimated at over $150 million per unit when development costs were included, made it an unaffordable luxury during wartime. General Norton Schwartz, then Air Force Chief of Staff, found himself in the impossible position of defending a program he believed was essential while acknowledging the fiscal realities that made expansion politically untenable. The F-22 represents our commitment to maintaining air superiority in any conflict against any opponent, he testified before Congress. But I also understand that we must balance future capabilities against current needs, and today our airmen are fighting wars that require different tools. The termination of production created a unique situation in military aviation history, a weapon system so advanced that it could not be replaced, but so expensive that it could not be afforded in meaningful numbers. The 187 F-22s that rolled off production lines represented both the pinnacle of American aerospace achievement and a cautionary tale about the limits of technological ambition in an era of fiscal constraint. Intelligence reports emerging during this period revealed the extent to which foreign nations were studying F-22 operations and developing countermeasures. Chinese and Russian military publications began discussing anti-stealth technologies with increasing frequency, while their defense industries invested heavily in radar systems designed to detect low-observable aircraft. The arms race that the F-22 was designed to dominate was evolving in unexpected directions, with adversaries choosing to develop asymmetric responses rather than attempting to match American capabilities directly. The psychological warfare aspects of F-22 operations became more complex as potential adversaries developed sophisticated understanding of the aircraft's capabilities and limitations. Intelligence analysts noted that enemy forces were adapting their tactics to assume F-22 presence, using distributed operations and mobile defensive systems that minimized the impact of traditional air superiority platforms. The invincible aura surrounding the Raptor began to fade as adversaries demonstrated they could operate effectively even while assuming they might be under surveillance by invisible opponents. Colonel Marcus Torch Williams, who commanded F-22 operations during some of the program's most challenging periods, reflected on the evolving nature of the threat environment. Our enemies were learning that they didn't need to match our capabilities to counter them. By assuming we were always present and planning accordingly, they could minimize our advantages while avoiding direct confrontation. It was a chess game where our opponent decided to play by different rules. Despite these challenges, F-22 operations continued to demonstrate the aircraft's unmatched capabilities in carefully selected engagements. The 2018 strikes against Syrian chemical weapons facilities showcased the Raptor's ability to penetrate sophisticated air defense networks and deliver precision strikes without detection. However, these operations also revealed the limitations of relying on such a small fleet of ultra-high-performance aircraft for routine military operations. Maintenance challenges intensified as the F-22 fleet aged without the benefit of ongoing production to provide spare parts and system upgrades. The specialized materials and manufacturing processes required to maintain stealth characteristics created supply chain vulnerabilities that affected aircraft availability. Mission-capable rates, the percentage of aircraft ready for combat at any given time, began declining as maintenance crews struggled to keep aging systems operational without adequate parts inventory. The recognition that F-22 production could not be restarted without enormous cost led to increased emphasis on extending the service life of existing aircraft. Upgrade programs focused on modernizing avionics and weapons systems while preserving the fundamental stealth and performance characteristics that made the aircraft unique. These modifications required careful engineering to avoid compromising the delicate balance of systems that enabled the F-22's extraordinary capabilities. As the 2010s drew to a close, the F-22 Raptor found itself in a paradoxical position. Universally recognized as the world's most capable air superiority fighter, it nonetheless faced an uncertain future due to small fleet size, high operating costs, and evolving threat environments. The aircraft that had been designed to dominate 21st-century skies was discovering that technological supremacy alone could not guarantee strategic success in a world where adversaries chose asymmetric responses over direct confrontation. The lessons learned during this period of crisis and adaptation would prove crucial as the F-22 program entered its third decade of operations. The Silver Phantom had survived its greatest challenges not through technological prowess alone, but through the dedication of the people who flew, maintained, and supported it. In facing its limitations, the F-22 community had discovered truths about modern warfare that would influence military aviation for generations to come. As the third decade of the 21st century unfolds, the F-22 Raptor stands as both a monument to American aerospace achievement and a harbinger of warfare's future. The 187 Silver Phantoms scattered across Air Force bases from Alaska to Virginia represent more than just the world's most advanced fighter aircraft. They embody a philosophy of air power that has fundamentally altered how nations approach conflict in the modern era. The lessons learned from 3 decades of Raptor development and operations continue to ripple through military planning offices, defense contractors, and strategic think tanks around the globe. The COVID-19 pandemic of 2020 created unexpected opportunities to demonstrate the F-22's strategic flexibility. As global tensions simmered and traditional diplomatic engagement became limited, the deployment of Raptors to forward operating bases served as powerful signals of resolve without requiring human contact or elaborate ceremonies. The aircraft's ability to project power while maintaining social distancing protocols highlighted advantages that designers never anticipated when the program began in the 1980s. Recent operations have showcased the F-22's evolution into what military strategists now term a sensor-shooter platform. The aircraft's role has expanded far beyond traditional air-to-air combat to encompass intelligence gathering, electronic warfare, and battlefield management functions. During joint exercises with NATO allies, F-22 pilots routinely serve as airborne battle managers, using their aircraft's advanced sensors to coordinate the actions of entire air wings while remaining invisible to opposing forces. Lieutenant Colonel Sarah Viper Chun, one of the newest generation of F-22 pilots, represents the evolution of aircrew training and mindset. "When I first transitioned to the Raptor, I thought I was learning to fly a fighter," she explains. "What I discovered was that I was learning to orchestrate warfare from an invisible command post that happens to be capable of supersonic flight. The aircraft doesn't just make you a better fighter pilot, it makes you a better military strategist." The F-22's influence on adversary behavior has become increasingly sophisticated as potential opponents develop comprehensive understanding of American stealth capabilities. Chinese and Russian military exercises now routinely assume F-22 presence, with participating forces practicing tactics designed to minimize the impact of undetectable opponents. This adaptation represents both a tribute to the Raptor's effectiveness and a preview of how future conflicts might unfold, with adversaries choosing to fight around American advantages rather than attempt to match them directly. Intelligence assessments from the Pacific Theater reveal the extent to which F-22 deployments influence regional stability. The rotation of Raptors through Guam, Japan, and allied bases throughout the Asia-Pacific serves as a constant reminder of American commitment to regional security. Chinese military publications acknowledge that the presence of even small numbers of F-22s fundamentally alters their operational planning, forcing the adoption of more cautious and distributed approaches to any potential conflict. The maintenance and sustainment challenges that have defined much of the F-22's operational history continue to drive innovation in aerospace support technologies. The development of additive manufacturing techniques, or 3D printing, has revolutionized the production of replacement parts for systems that were never designed with such technology in mind. Master Sergeant David Rodriguez, a veteran F-22 crew chief, describes the transformation. "We've gone from waiting months for specialized components to printing critical parts in hours. It's like having a mini factory in the maintenance bay." Stealth technology maintenance has evolved from an art practiced by a few specialists into a more systematic science. The development of portable radar cross-section measurement systems allows maintenance crews to verify an aircraft's stealth characteristics without requiring return to specialized facilities. These advances have dramatically improved the F-22's operational availability while reducing the logistics footprint required for forward deployment. The F-22's combat record, while limited due to the nature of its missions and the classified aspects of many operations, continues to demonstrate effectiveness that validates the original design philosophy. The aircraft's ability to engage targets while remaining undetected has created tactical scenarios that were previously impossible. Enemy forces find themselves in the unprecedented position of facing an opponent who can observe, assess, and engage without ever revealing their presence. Pilot testimonies from recent operations describe engagement profiles that seem drawn from science fiction. The ability to track dozens of aircraft across hundreds of miles while remaining completely invisible creates tactical advantages that fundamentally alter the nature of air combat. Major Kevin "Ghost" Patterson recounts a recent training mission. "I watched an entire enemy air wing deploy, tracked their movements for over an hour, and eliminated their lead elements before they ever knew I was in the same airspace. It's not just air superiority, it's air dominance at a level that previous generations of fighters couldn't achieve." The F-22's role in developing next-generation air combat tactics has extended far beyond Air Force operations. The aircraft serves as a test platform for concepts that will define the characteristics of future fighter designs. The integration of artificial intelligence systems, advanced sensor networks, and autonomous weapons platforms all trace their operational concepts to lessons learned from F-22 employment. International partners and allies have consistently requested opportunities to train with F-22s, recognizing that exposure to fifth-generation capabilities is essential for maintaining interoperability in future conflicts. These training exchanges have revealed both the aircraft's overwhelming advantages and the challenges of integrating such advanced capabilities with conventional forces. Allied pilots described flying alongside F-22s as simultaneously inspiring and humbling, providing clear demonstrations of what next-generation air power can achieve. The economic impact of the F-22 program extends far beyond the aircraft themselves. The technological advances developed for the Raptor have found applications throughout the aerospace industry, from commercial aviation to space exploration. Manufacturing techniques pioneered for stealth aircraft construction now influence everything from automotive design to architectural engineering. The program's investment in advanced materials and manufacturing processes continues to generate returns across multiple industries decades after the initial research was conducted. As global tensions increase and new adversaries develop increasingly sophisticated capabilities, the F-22's strategic value has only grown. The aircraft that was once criticized as being too expensive for the threats it was designed to counter now appears remarkably prescient as China and Russia deploy advanced fighter aircraft and integrated air defense systems. The 187 Raptors represent an insurance policy against scenarios that seemed unlikely when the aircraft entered service but appear increasingly probable today. The legacy of the F-22 Raptor extends far beyond its direct military contributions. The aircraft demonstrated that American aerospace industry could still produce revolutionary technologies that fundamentally altered the strategic balance. It proved that stealth, advanced sensors, and information dominance could be more valuable than traditional metrics of speed and armament. Most importantly, it established the template for 21st-century air warfare that continues to influence military planning and defense development worldwide. Looking toward the horizon, the F-22 faces the inevitable reality of aging systems and the emergence of new threats designed specifically to counter its advantages. Yet the aircraft's most important contribution may prove to be the lessons it taught about the nature of modern conflict. The Raptor showed that in an era of precision weapons and global communications, the ability to operate undetected while maintaining complete situational awareness represents the ultimate tactical advantage. The Silver Guardian that emerged from the dreams of Cold War engineers has become something its creators never fully anticipated, not just a superior fighter aircraft, but a catalyst for rethinking how advanced nations approach warfare in the modern era. As new generations of pilots take the controls of these remarkable machines, they carry forward not just advanced technology, but a philosophy of air power that will continue shaping military aviation long after the last F-22 has been retired. The invisible empire built by 187 aircraft has proven that sometimes the most profound revolutions come not from what can be seen, but from what remains forever hidden in the shadows of the sky.